Hi, you are welcome to my channel. Today we are going to discuss about another important topic in chemistry called mole concept. Mole concept. If you are a student preparing for WAEC, for JAM, or for post-UNE, follow this class till the end because you cannot escape questions on mole concepts. Then in today's topic, I'm going to give you 3 tips on how to answer questions on mole concepts. I will give you 3 tips on how to answer questions on mole concepts. Now let's first define the word mole. Mole is a unit of measurement. Mole is a unit of measurement. So it is a standard unit. It is a standard unit. So we use it to determine the specific quantity or amount of what? Of a substance. We use it to determine the specific quantity or amount of a substance. I can also define mole as collection of units. Collection of units. For example, if I say a pair of socks, that means 2 pieces of socks. Then if I say a dozen of socks, that is what? 12 pieces of what? Of socks. So there is a specific amount. So the collection of 12 pieces of socks is called what? A dozen of what? Dozen of socks. So more is talking about what? Collection of units. Collection of units, which is similar to other familiar units. So what are the tips? Before we talk about the tips to solve questions on mole concepts, so let's define mole. Mole can be defined as the amount of substance that contains as many elementary units as there are atoms in 12 grams of carbon-12. Mole can be defined as the amount of substance that contain as many elementary units as there are atoms in 12 grams of what? Of carbon-12. So mole is also talking about the amount of particles. The amount of particles. Then what is particle? A particle is a small piece of matter. A particle is a small piece of matter. Then we are talking about the particulate nature of matter. We'll talk about atoms, ions, and molecules. So mole can we can use numerical value to calculate what? The number of moles, because when we are talking about atoms, ions, or molecules, they are too tiny. They are too tiny to be seen. So aggregate or collection of atoms is called what? Is called mole. So we have 3 tips. We have 3 tips that we can use to solve questions on mole concepts. The first one is called mass-mole relationship. So the first tip is mass-mole relationship. Then under mass-mole relationship, you say 1 mole of any substance equal to the relative molecular mass. Equal to the relative molecular mass. So that's the first tip. Then the second tip is talking about 1 mole of an atom. So I will call the second tip mass and atoms or ions or molecule relationship. So mass, atoms, or ions or molecule relationship. You use this mass, atoms, or ion or molecule relationship when your question is talking about calculate the number of an atom or calculate the number of molecules of a so given mass, a substance in gram. So when your question is talking about the mass of a substance and the number of atom or the number of molecule, you use what we call what? Mass molecule relationship. Then the first step to take is to write that the number of mole of any atom or 1 mole of any atom. So it can be an atom, it can be an ion, it can be what? A molecule. 1 mole of any atom is equal to your Avogadro's number. 1 mole of any atom, that is the first step to take, the first thing to write. 1 mole of any atom equal to your what? Avogadro's number. So when your question is talking about what? Mass atom relationship, then they can also give you the number of mole. Then don't forget that 1 mole of any atom is equal to the what? The molar mass of that substance. Then the molar mass of a substance is in gram. So the molar mass will be given in gram. Then the third one is mass volume relationship. Mass volume relationship. So when your question is talking about mass and the volume of what? Of a gas. When your question is talking about the mass and the volume of a gas, so you use what? Mass volume relationship. Then the volume of any gas is equal to 22.4 dm cube. So volume of any gas, the first thing to write is volume of any gas equal to 22.4 dm cube. So that is the first step to take when your question is talking about mass and volume. So let's use the following tips to answer these questions on on mole concepts. Let's use the following tips to answer questions on mole concepts. So let's look at number 1 question solution. Number 1. Let's look at that number 1 question. What is the amount? Don't forget that amount is also known as mole. So number 1 thing is what? This question is talking about mole. What is the amount, which is mole, of what? Of gold present in 15.5 grams. So anything in grams is what? Is mass of a substance. So mole and what? And mass. So this question is talking about what? The number of mole and mass what? Of a substance. So which one will be suitable? We use the first tip. So which is talking about what? Mass mole relationship. So what's the first thing we are going to write now? So which substance are they talking about? Because the first step is to write 1 mole of any substance. 1 mole of a substance. So which substance are they talking about? That is gold. So our substance is gold. So what are we going to write now? We'll say 1 mole of gold, which is Au. Symbol for gold is Au. 1 mole of gold equal to 1 mole of any substance equal to the relative molecular mass of the substance. So 1 mole of gold equal to the what? The molar mass of gold. Then the molar mass of gold is 197. So equal to 197. That is the first step. So 1 mole of a substance, when they give you question on mass mole, 1 mole of that substance given from the question is equal to the molar mass of the substance. So which substance are we talking about here? Gold. 1 mole of gold equal to the molar mass of gold, which is 197. Now, let's go back to the question. So the question says, what is the amount? What is the amount? That is, we are looking for what? The number of mole. Don't forget that amount is also known as mole. So we are looking for the number of mole. So you come under mole. This side is for mole. While this side is for what? For mass in gram. This side is for mass in gram. So this side is for mole. So you are looking for the number of mole. Then you say X mole. X mole of gold equal to what amount of gold present in 15.5 grams. So they gave us what? Mass in gram. Mass in gram is given. So let's come under mass. So place that 15.5 gram under what? Under mass. So this side is for mass. Then that's 15.5 grams. 15.5 grams. So after that, you cross multiply. So 1 times, let's start with this, X times 197, that is X mole times 197 grams. It will give us 197 gram x mole equal to 1 times cross multiply, so 1 times 15.5 grams will give us 15.5 grams. 15.5 grams. Now to get the number of mole, x mole, we divide both sides by 197 grams. So divide this side by 197 what? Grams. So 197 we cancel what? 197. So our x mole will now be equal to, so by the time you use 15.5 grams to divide 197 grams, your answer will be 0.0787. Then the unit is in what? We are looking for the mole. The number of mole is, the unit is mol, mole. So that is the answer for the first one. That is the answer for the first one. So let's move to the second question. Question 2. Questions number 2. So what are those things that we need, or what are the parameters given from the questions? The question says calculate the mass. So the first thing mentioned from this question is what? Is mass. Calculate the mass of, is 0.15 mole. So which means that we need the number of mole. Another thing is what? Is mole of Na2CO3.10H2O. So we are going to need the molar mass of this compound, because this is a compound. It is not what? It is not an atom. It is not an element. So we are going to look for the molar mass of this compound. But this question is talking about mass mole. So we use what? The mass mole relationship to solve the question. We use the mass mole relationship to solve the questions. So let's first look for the relative molecular mass of Na2CO3.10H2O. So we are going to use mass mole relationship to solve that question. So we need the molar mass of Na2CO3.10H2O. Then what is Na2CO3.10H2O? That's sodium triazocarbonate 4 decahydrate. Those sodium, it is called sodium triazocarbonate 4 decahydrate. Now let's look for the molar mass. So you look for the atomic mass of each element present in this compound and you add them together. So the first element is sodium. Then what is the atomic mass of sodium? That is 23 times 2. We have 2 sodium. Then plus the atomic mass of carbon is what? Is 12. Is 12. Then plus the atomic mass of oxygen is 16. Then 16 times 3, because we have what? 3 oxygen. Then plus 10 into bracket. The atomic mass of hydrogen is 1. So times 2. Plus the atomic mass of oxygen is what? Is 16. So let's add everything together. It will give us 23 times 2 will give us 23 times 2 will give us 46. 46 plus 12. Then plus 16 times 3, that is 48. Then plus 1 times 2 plus 16, that is 18. Then 18 times 10 will give us 180. So let's add everything together. So 12 plus 48 will give us 60. Now 60 plus 180. 60 plus 180 will give us 240. So 240 plus 46. 240 plus 46 will give us 286. 286. So the total mass equal to 286. So 286 what? Gram. 286 grams. So that is the molar mass of the substance. Then we now go back since our question is talking about the mass and the number of mole, so the first thing to say now is 1 mole of Na2CO3.10H2O equal to the molar mass of this Na2CO3.10H2O. Then what is our molar mass? That is 286 grams. 286 grams. Then we now go back to the question. Then we have what? 0.105 mole. So 0.105 mole is given. So we come under the number of mole. This is mole side, while this is mass in gram side. So we come under this number of mole, write that is 0.105 mole of Na2CO3.10H2O equal to X. So we are looking for the mass. They said calculate the mass. So we are looking for the mass in what? Mass in gram. So then now we cross multiply. So 1 times X will give us what? X gram equal to 0.105 times 286. 0.105 times 286. So 0.105 times 286 will give us 30 grams. 30 grams. So it shows that the mass of what? The mass that will be equivalent to what is 0.105 mole of sodium triisobicarbonate 4 decahydrate is what? Is 30 grams. 30 grams. So number 3. Let's solve questions 3. So let's check the parameter given from that question 3. A chip used in a microcomputer contains 5.74 gram, 5.74 times 10 raised to power minus 3 gram. Anything in gram is the mass of a substance. So for this question now, we need mass. We need mass of silicon. So this is the mass of silicon. Now calculate the number of silicon atom. So we need what? An atom. We want to calculate the number of an atom. So when we are talking about mass and atom, we use the second tip, which is called what? Mass atom relationship. Mass atom relationship. Then the first step to take is 1 mole of that atom. So which atom are we talking about now? We are talking about silicon. So they mention silicon from this question now. So the first step to take is to write that 1 mole of what? Of silicon atom is equal to your Avogadro's constant. That's the first step to take. So now you write 1 mole of silicon atom equal to your what? Your Avogadro's number, which is 6.023 times 10 raised to power 23. That is the first step to take. Then you now go back to your question. So now from our question we have mass in gram. Mass in gram of what? Of silicon. So you come under mass in gram. Then don't forget that 1 mole of any atom is equivalent to the what? The molar mass of that atom. So I can change this 1 mole to the mass of silicon. So what is the mass of silicon now? 1 mole of silicon is equal to the what? The molecular mass of silicon. So what is the mass of silicon is what? Mass of silicon is 28. So I will now say that 28 gram of silicon atom equal to 6.02 times 10 raised to power 23. So the mass of silicon is given, which is 5.74 times 10 raised to power minus 3. So place this 5.74 times 10 raised to power minus 3 in gram, because it is mass in gram. Put it under what? Under mass. So this side is for mass, while this side is for what? Is for atom. So this is an atom now. So 5.74 74 times 10 raised to power minus 3 gram of silicon equal to, so what are we looking for? Calculate the number of silicon atom. So we are looking for the number of atoms. So you write X atom. So silicon, 1 mole of silicon is equal to what? 6.023 times 10 raised to power 23 atom. So we cross multiply now. So by the time you cross multiply, your X atom, your 28 gram times X atom equal to 5.74 times 10 raised to power minus 3 times 6.023 times 10 raised to power 23. Then divided by, so divide both sides by 28 grams. Divided by 28 grams. So 28 grams, we cancel 28 grams. So we have X atom equal to, so 5 times 74 times 10 raised to power minus 3 times 6.02 times 10 raised to power 23 divided by 28 will give us 1.23 times 10 raised to power 20. So the final answer will be 1.23 times 10 raised to power 20 atoms. Times 10 raised to power 20 atoms. Then let's proceed to questions 4. Questions number 4. Number 4. So let's read that questions 4 to know the formula to apply. So how many molecules? So this question is talking about molecule. It's talking about molecule. How many molecules are in 25.5 grams? Anything in gram is what? Is mass. So the question is talking about what? Molecule and mass in gram. So which formula are we going to apply? We apply what? The second tip, which is 1 mole of any atom or molecule or an ion is equal to what? Your what? Avogadro's constant. So that's the first step to take now. So 1 mole of how many molecules are in 25.5 grams of ammonia. So the substance or the molecule is what? The molecule is what? Is an ammonia. 1 mole of ammonia or 1 molecule of ammonia, that is NH3, equal to your Avogadro's constant, 6.023 times 10 raised to power 23 molecule. So that's the first step to take. That's the first step to take. Then from this now, since ammonia is not an element, it is a molecule. So we have to look for the what? The relative molecular mass of ammonia. So what is the relative molecular mass of ammonia? So you add the atomic mass of each atoms together. So the atomic mass of nitrogen is 14 plus the atomic mass of hydrogen is 1, then times 3. So since we have 3 atoms of hydrogen, so we have 3 atoms of hydrogen times 3, which is equal to 14 plus 3. 14 plus 3, which is equal to 17 grams. 17 grams. So now, let's go back to the first step. 1 molecule of ammonia, then 1 molecule or the 1 mole of ammonia is equivalent to the what? The mass of what? The mass of ammonia. So which means that 17 grams of ammonia, 17 grams of ammonia equal to the what? The Avogadro's number. equal to our Avogadro's number. Then let's go back to the question. We have what? 25.5 grams of ammonia. So mass in gram should be placed under what? Under mass in grams. So this side is for mass. Then why this side is for what? For molecule. So place this 25.5 grams under mass in grams. So 25.5 grams of ammonia equal to, so what are you looking for? How many molecules? Equal to the number of molecules. That's X what? Molecule. X molecules. Then you cross multiply. So by the time you cross multiply, X molecules will be equal to 25.5 times your Avogadro's number. So that's 25.5 times 6.023 times 10 raised to power 23. Then divided by 17 grams. Divided by 17. So your X molecule. So what will be the value for our X molecule? That is 9.03 times 10 raised to power 23. So our final will be, the final answer, our final answer will be 9.03 times 10 raised to power 23 molecule. Times 10 raised to power 23 molecules. So I believe we are following. Then let's solve the last question under this topic. Number 5. Questions number 5. So the volume occupies. So the first thing mentioned from this question is what? Volume. So we need volume. The volume occupied by 1.58 grams. Anything in gram is what? Is mass. So we need mass. So this question is talking about what? Mass volume relationship. Then what will be the first step to take? The volume of that gas equivalent to what? 22.4, because volume of any gas is equal to what? 22.4 dm cube. So what's the first step to take now? So volume of, so what's the name of the gas? The volume occupied by 1.5 grams of a gas. So we don't know that gas, so we can call it X gas. So volume of X gas equal to 22.4 dm cube. So that is the first step to take. Volume of any gas equals to what? 22.4 dm cube. Then go back to the question. So now the volume occupied by 1.5 grams of, the volume occupies by 1.58 grams of a gas. So the mass in what? In gram is 1.59. So come under here and write your what? Your mass in gram. So, or let's say 1 mole of any gas, 1 mole of X gas. So the mass of that 1 mole of X gas is what? 1.58 gram. So 1.58 gram of X gas, because we don't know that gas, equal to, so 1.58 gram of a gas at STP is 500 centimeter cube. So they've given us what? The volume of this 1.58 grams, which is equal to 500 centimeter cube. So this one is in centimeter, which is the volume, while this one is in dm cube. So we convert this one also to what? To dm cube. So therefore, we are looking for the what? What is the relative molecular mass of the gas? So we are looking for the mass of that gas. We don't know the mass of the gas. So we now say that X gram of gas X equal to, so let's convert this 22.4 to dm cube. 1 dm cube is equivalent to 1000 centimeter cube. So multiply 1000 centimeter cube by 22.4 times 1000. So to convert it to centimeter cube, then 1.58 grams of gas X equal to 500 centimeter cube. So this one too is also in centimeter cube now. Then we cross multiply. So we are looking for what? The mass of what? Of gas X. So X gram will now be equal to 1.58 times 22.4 times 1000, then divided by 500 centimeter cube. So which is equal to, so what will be our answer? Which is equal to 71 grams. So by the time you multiply what you have up, denominator together, and you divide by the denominator, your answer will be 71 grams. 71 grams. So which means that 71 grams of what? Of gas X equal to 22.4 dm cube. Or of learning. Subscribe to Royal Learning channel. So learn at any time and anywhere. Share this video with your friends and comment. Bye.